All right, lesson 4.1. Good news is we've actually done this before. So this was Math 9. This is equation of a line. You guys remember that game we were playing with making your own equation on the computer there? Where you could like, it's pretty much that. We just need to be able to figure out our slope and our y-intercept, and then we really have our equation of our line, right? So just as a bit of review, where we're heading here is the equation y is equal to mx plus b, right? And then there's really only two parts of this, right? So it's an equation. We just need to find what m is, and we need to find what b is, and then that's the equation of our line, right? So m, if you remember, was our slope. So another way of saying slope is our change in y divided by our change in x. The mathy way of showing that, you guys have probably seen this in physics as well, is with the triangle. So that's change in y over change in x, which really just is our rise over our run, right? So we've been talking about slope is rise over run. It's the same thing, but now our rise is just going to be our, like, how much it goes up in the y and how much it goes over in the x, right? So this equation, you guys have this on your formula sheet as well. M is equal to y2 minus y1, x2 minus x1. This one always confuses people, but it's really not that bad because this is just saying, so if I took, you know, some point here and then some point there, and then label those points. So if this is my x1 and this is my y1, this is my x2 and this is my y2, right? So like in this case, this would be -3 comma -4, right? Like those would actually be numbers in there. Then, and this one would be, what's that, 4 comma 4. Then we could figure out the slope of this thing by just going y2, like this one, minus y1, and then x2 minus x1. But if you think about what we're doing here, when I go y2 minus y1, what I'm really finding is my rise, right? That I'm finding the difference between this height and this height, right? So that still just is our rise. And if you want to just keep counting the boxes like we pretty much mostly did in grade 9, that's fine. You can make a little triangle, you can count the boxes, but just know that there is going to be situations, especially in math, as opposed to physics, where we have 2 points and we have to find the slope. We'll do examples like that, but we'll just be throwing it into this equation. But that really is just rise over run. Okay? All right. So, if you guys remember from last year, if we have a slope that starts low and ends high, is that a positive or a negative slope? Positive slope, right? And you can think that it rises up and then runs, you know, goes up and then over. Where if we have a negative slope, then we think about this thing as going down and then over, right? And we'll give you some examples of that later. Okay. If we have a horizontal line, like this one, then there's kind of only two answers here. You're going to have zero slope or you're going to have undefined slope. Let's talk about why this one would have a slope of 0 and why this one you would say it's undefined or like does not exist or something like that, right? The reason for this is because you can imagine this line here, right? If we're figuring out the rise over the run, well, what would let's do the run first. I can actually say there is a run here, right? This thing has a run at 6. But what would the rise be? How much is it going up? Yeah, 0, right? So you could say this was 0 over 6. What is 0 divided by 6? 0. It's 0, right? That's still a number, right? So that's still m is equal to 0. But let's look in this example. So now we have this thing that's going straight up and down. So this thing has so if I'm going rise over run, the rise of this one I can calculate, right? Because it starts here and ends here. So that goes 6 up for my rise. But what's my run? 0. What do you get if you go 6 divided by 0?
6.
What's that? No. Can you guys right now, just so you can like see it for yourselves, what do you get if you go in your calculator and you go 6 divided by 0? What does your calculator tell you? Yeah, so you should get an error in your calculator. Do you guys know why you get an error if you divide by 0? Yeah, it's not possible. Imagine it this way, right? If I said I had like 6 cookies and I divided into 0 groups, how many cookies does everyone get? It just doesn't actually even make any sense. It doesn't work out, right? So you can't divide by 0, right? It's not infinity. It's not anything. It just doesn't work.
So why does multiplying by 0 work then?
Because if I had 6 cookies, here.
6 times 0 equals
just
what?
Okay, so anyway, this ends up being undefined, right? We were just talking about multiplying by 0 there, if you're watching the video. All right, so, all right, first one here, determine the slope of each line segment. So a good way to do this is to just draw a triangle, right? And I know you guys in science right now are doing the same thing, right? So how much does this thing rise?
Oh.
Well, in this case, you can look at the boxes, right? How many you can even count them because they go up by 1 in this case.
8.
So counting up the boxes there, this thing rises 8. And what does it run?
4. Negative 4.
1, 2, 3, 4, 5, 6. 6, yeah. Okay, so the slope of this, so slope is equal to rise over run. So the slope of this would just be 8 over 6. Now we wouldn't leave it that way. We'd like to make it as reduced as we can. So what goes into 8 and 6? 2, so we'll divide them both by 2, right? So 8 divided by 2 is 4 over 3. So do you guys see too while I'm looking at this? So 8 over 6. This means I could also go over 3 up. Oh, that didn't work out for the lines there. Huh. Well, it should be the case. I think my scale's off a little bit on this thing, that I should be able to also go over 3 up 4 and land on that. Did I count wrong here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Someone told me 8.
I said
All right, sorry, that should have been 9 over 6.
So it would be 3 over 3.
Yeah, so we'll divide them both top and bottom by 3. So m is equal to 3 over 2. Yeah, so 3 over 2. So this should work out now, right? We go over 2, up 3, and we still land on the line, right? So it doesn't matter where you make that triangle, right? 3 over 2 is the same thing as 9 over 6. The slope, there's only one value for the slope for that whole thing. So you can make your triangle wherever you like there, right? Okay, let's do this one quickly. So I can make another triangle here. I'm going to use the whole thing because I just know for sure that it passes through those 2 points because they've made a point of making a point. Okay, so it goes. Well, they actually made like a dot there, right? So I know it goes through there. So it goes down 3 over 9.
Maybe count before you press count.
Yep. Okay, so would I say then that this thing has a slope, an m value of 3 over 9? Well, we should simplify it, right? We'll do that too. So m is equal to, divide the top and the bottom by 3. So that's going to be 1 over 3. Negative. Why was it negative? You're going down, right? And you can kind of recognize those pretty quick too, right? If you're starting high, going low, it's like you're going down a hill. You know, you're going into the negative there. But what really happened here, this was like negative 3 over 9, right? So that was really negative 3 over 9, which would simplify to negative 1 over 3. All right, now let's do this one. So they've just given us 2 points. So one strategy we could use, we could just actually plot it like this, right? Like, and then make a triangle and figure that out. But probably the easier way here is to use our little formula, right? So our formula was m is equal to y2 minus y1 over x2 minus x1, which really just is the rise over the run. Okay, so now we just got to figure out what our y's and x's really are, right? So let's just label them right on top of the points here. I'm going to call this my x1 and this my x2. I'm going to call the next one, so that's going to be my x2, and that'll be my y2. Oh, sorry, my bad, guys. x1, y1.
You had like 3 X's.
Okay, you guys are good now?
So does that? Oh, wait.
So we have all our points, and now we can just kind of throw them all in, right? So m is equal to, so y2 minus y1. So that's going to be 6 minus, and then careful on this though, because it's 6 minus, and is it minus 5?
No, because it'd be plus 1 because negatives can't.
Right, it's really minus, and then I put it in brackets, minus -5. If you're going to make a mistake on this, it's probably going to be right there. So just careful on that one.
That looks like a positive.
Over, and then x2 minus x1, so that's going to be 8 minus 4. Okay, so this was really, so 6 minus -5 is really like 6 plus 5. So that's going to be 11. So slope is going to be 11 over, and then 8 minus 4 is 4. There you go, there's our slope. All right, number 2. Draw the following line segments. So beginning at point -3, -2, we want to make this thing have a slope of 4 over 9. Okay, so in order to do this, we're going to have to make our own little axes here. So if you have a ruler, this would be a good place to do it. There's a straight edge, but let's make it. Rulers don't work well on a computer. So something like that. Okay, so very first thing we got to do on this first one is plot the point -3, -2. Okay, so I'm going to the left 3, and I'm going down 2, right? So there's my first point. So that was the point -3, -2. And then the only other thing they told us is that this has a slope of 4 over 9. Any ideas on how we can handle this? Yep.
You go up 4 over 9.
Nice. Yeah. It has a rise of 4 and a run of 9. So we can just we have a starting place, right? We can start here. But then I know from there I have to go, you can either go over 9 up 4 or up 4 over 9. It'd be the same thing, right? So I'm going to go up 4, so you count 1, 2, 3, 4. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, this thing went up 4 over 9. So then if we connect those 2 points I just made, then with a straight edge, then that would be my line. And the other thing, guys, notice that I made my line just go forever, right? Because this is a line. Oh, I guess no, I shouldn't do that because this one does say it's beginning at this point and then has that. Oh, and it does say line segment. My bad. Line segment would just mean that we connect those 2 dots and leave it there. A segment would have a beginning and an end. So from our start to our end. If it would have just said line, we would have ended up making it go on forever. Okay, can you guys do the next one? So guys, you should have been able to plot your first point, right? And then here's the new thing, -8 over 3, right? Just remember when you have -8 over 3, that could be written as -8 over 3, right? Where the negative is like attached to the 8. And that's typically the best way to do this, where we'll just go down 8 over 3. So from this point, I should be counting down 8, right? So 1, 2, 3, 4, 5, 6, 7. I go off my graph here, but that's all right. So down 8 over 3. So it should be about there. Yeah, and then to the right 3. Yeah, you wouldn't go backwards 3. And then connect those points.
You messed me up.
Quickly, so Tom has a part-time job. He recorded the hours he worked and his pay for 3 different days. Tom plotted these data on a grid. What is the slope of the line through these points? So if you really could make a line through those points, what would the slope be? Yeah, careful here because now we can't just count the boxes, right? In the other examples, we were going up by 1. Every box represented 1, right? In this case, our pay is going up by 12, right? Like every one of these boxes is 12. So we got to be a little careful on this. So let's make our triangle. We can make our triangle wherever we like. Maybe I'll make it from, from here to here. I could have, if I wanted to, though, made it the whole thing. It wouldn't have mattered. Okay, so our rise here, what would our rise on that triangle I just made be?
Not bad, boy. 24.
24, right? It goes up to 24. And what would our run be? 2. Okay, so I think we have everything we need. So for A, our slope, M, would be 24. And we really should put our units here too, right? This is like a real world situation. This is 24 what? Dollars, right? Dollars are the weird unit that goes on the left side of the number instead of the right side of the number. So dollars per, and then my run here was every 2 hours. Okay, we should probably simplify that, right? So that would be the same thing as, so this will be 24 divided by 2, or simplifying them both. We get $12 per 1 hour, or just per hour, right? Written like that. So we kind of answered B, didn't we? What does the slope represent? Money over hours, yeah. So how many dollars he makes per hour, right, is the slope on that one? Per every 1 hour. Okay, so how can the answer to part B be used to determine how much Tom earned in 3 hours? So what would we do there? If you and just use your common sense on this. Some of you guys are working, right? If you made $12 an hour and you worked for 3 hours, how much money did you make? 36, right? What did you do there? You went, right, you went 12 times 3, right? Because if I make $12 every hour, I multiply that by 3 hours, I'm going to make $36, right?
That's under minimum wage.
You cube it, don't you?
So the other half of this, it says the time it took Tom to earn $30. So the other way, yeah, so you can think about it this way too. We can make a little equation, right? So we can be like earnings is equal to $12 per hour times the number of hours you work. So times maybe time, right? So in this case, if I earn $30, I'm really just looking for time now, right? What would I do if you were just trying to get time on its own? You just divide by 12, right? So divide by 12. So 30 divided by 12. So it ends up being, yeah, 2.5 hours. Yeah.